All right, let's dive right into this. Welcome to today's Explainer, where we are going to completely transform how you approach your Cambridge Physics 0625 exams. Look, if you've been relying on rote memorization, just endlessly repeating textbook definitions and really hoping they'll somehow stick, you are absolutely in the right place to make a change today. We are focusing on reflection in plain mirrors, but honestly, more importantly, we're going to unlock the exact exam strategy that takes you from just knowing a bunch of isolated facts to actually mastering the application of those facts. We're going to build up your confidence so that when you walk into that exam room, you're ready for literally anything they throw at you.
So here's our roadmap for today. We'll start with the reflection challenge, then break down our 4-step framework. After that, we'll look at mastering cause and effect, dive into some real-world applications, cover common exam pitfalls, and wrap up with 4 memory prompts.
Let's get things off with Section 1, the reflection challenge.
I want you to consider this really vital question for a second. What physical effect, measurement, or prediction actually depends on understanding reflection in plain mirrors? Really think about that. We don't want to just introduce formal language and fancy formulas out of nowhere, right? A physics concept has to feel necessary. It shouldn't just be decorative. Because if you can't answer why this physical effect actually matters in the real world, all that formal language is just going to slip right out of your memory the second you close the book. We absolutely need to ground the physics in reality before we do anything else.
Grounding the topic like this brilliantly illustrates a core teaching philosophy from our source material, which is taking an application-first approach. By understanding exactly why reflection matters before you go and memorize all the terminology, you move completely past simply recalling memorized wording. And this is a total game changer. When an examiner throws a tricky, unfamiliar scenario at you, and trust me, they absolutely will, you won't panic. You won't just be sitting there frantically scanning your brain for a matching flashcard. Instead, you'll be able to actually reason your way through the exam confidently, relying entirely on core physical principles.
Moving right along to Section 2, the 4-step framework. Okay, so this is the crucial point. Think of this as your micro gateway sequence. Whenever you're studying reflection in plain mirrors, or honestly, pretty much any topic in the Rays and Waves chapter, you need to actively guide yourself through these 4 linked steps. Step 1, identify the exact quantity or phenomenon. Step 2, state the relationship involved. This is where your equations or specific rules come into play. Step 3, explain the underlying physics clearly. And Step 4, connect it all back to a real observation, a real experiment, or a specific device. This sequence is literally the ultimate formula for structuring those high-scoring, multi-mark answers in IGCSE-style physics.
Our source material really hits the nail on the head with this core truth. The best answers show both understanding and application. You see, examiners are not just looking for a data dump of raw knowledge. They don't just want a list of facts. They are actively hunting for the bridge between textbook theory and practical reality. If you only show understanding but totally skip the application, you are just leaving easy marks on the table. This 4-step framework guarantees that you cover both sides of that equation every single time you write an answer.
All right, Section 3, Mastering Cause and Effect.
Listen really closely to this piece of advice from the source. Insist on cause and effect rather than isolated facts. Whether you're dealing with waves, forces, fields, or in our case today, reflection in plain mirrors, isolated facts are just weak. A really good teacher at the board explanation always moves gradually from everyday language straight into precise physics vocabulary, usually by starting with a concrete example. And you know what? You should be studying the exact same way. Build a chain of events. A happens, which makes B occur, which finally results in C. That clear, logical cause and effect chain is exactly what examiners are trained to tick off on their mark schemes.
And hey, if your question involves data, you've got to apply that exact same physical logic. When you're interpreting graphs related to any physics topic, it is never, ever enough to just say the line goes up. You must stress what the slope, the area, the direction, or the shape means physically. Is that slope representing a speed? Is the area showing total distance? Tying the mathematical shape of the graph right back to the physical reality of the mirror or the wave, that is where the crucial exam marks are actually won.
Let's jump into Section 4, Real-World Applications. The physics of reflection in plain mirrors extends way, way beyond the walls of your classroom. Think about it. The exact same principles you're studying right now appear in structural engineering, road safety, transport, advanced energy systems, fiber optic communications, cutting-edge medical technology, and even astronomy. This isn't just dry theory. These are the actual rules that govern the technology we rely on every single day.
because this topic is just so widely applied in the real world, here is your challenge. As a focused learner, you should always keep at least one concrete real-world application right in your back pocket. But remember, just naming the application isn't going to cut it. You have to actually explain why the physics helps predict or improve outcomes in that specific situation. If you can do that, you instantly prove to the examiner that you grasp the true utility of the physics you're writing about.
Now for Section 5, Common Exam Pitfalls.
Let's take a second to compare some weak exam habits against a totally bulletproof strategy. A super common weakness is writing down a perfectly correct formula, but then completely failing to explain what the variables actually stand for. Another one is quoting a process, but never linking it back to a physical effect. Contrast that with what the source calls the safest method. Every single time you write an answer, make sure you have your definition, your relationship, your explanation, and your application. If you stick to that structure, you are actively defending yourself against losing those totally silly, avoidable marks.
And I really want to hammer this point home, because it's where so many students trip up. Never give an example without showing exactly why it follows from the physics. Just dropping an isolated fact or tossing a random example at the very end of a paragraph might feel like you're adding great detail, but to an examiner, it just looks like you're guessing. The reasoning chain that connects the core physics to your real-life example has to be totally explicit. Make them see the invisible strings connecting the theory right to the practice.
Finally, Section 6, 4 memory prompts.
If you want to guarantee your knowledge is totally secure, you need to test your recall. When you finish studying reflection and play mirrors, I want you to close your book and ask yourself these 4 specific prompts. 1. What is the core idea? 2. What changes physically? 3. What quantity or graph shows it? And 4. Where is it used? These aren't just random questions we made up. They are tailored precisely for IGCSE short answer and structured questions. They literally force you to recall the definition, the cause and effect, the data interpretation, and the application.
So I'm going to leave you with this final, slightly provocative thought. Can you answer these 4 memory prompts out loud right now to really secure your exam knowledge? Don't just nod along right now. Actually test yourself. If you can confidently answer them, you have truly mastered the application-first approach to this entire topic. Thank you so much for joining me for this explainer. Keep asking why, keep making those real-world connections, and I'll see you in the next one.